Okay, so we're going to move on to lesson 4. This is called descriptive statistics, name and date at the top. Descriptive statistics are going to be words like mean, median, and mode, lower quartile, upper quartile, that can be used to describe the data that we see or the statistics that we see. So we're going to find the measures of center and how data varies. This is going to be our mean or our median, and then our ranges. Okay, so I took the liberty of putting mine from least to greatest already, so take a moment to pause the video to rewrite the list from least to greatest. The data in the table represents the result of a survey about distance driven over spring break. Does the mean or median best represent the data? Explain. So we need to find the mean and the median. So to find the mean, we add them all up and then divide by the amount that there is. 1, 2, 3, 4, 6, 7, 8, 9, 10. So we're going to divide by 10. We're just going to go ahead and add all those up. So 209 plus 219 plus 256 plus 257 plus 277 plus 293 plus 296 plus 302 plus 312 plus 749. We have 3,170 divided by 10 is going to be 317. That's our mean. The median requires us to order these from least to greatest, which I did, and then find the number in the middle. So I'm just going to go through the list. I've got two numbers in the middle, so I need to add those up and then divide by 2, finding the mean basically of the middle one. 277 plus 293 divided by 2, so that's 570 divided by 2 is 285. And they're asking us, this would be miles, which one is more appropriate, 317 or 285? So which one is closer to the rest of them? If you look here, we got some in the lower 200s, a lot. Do we have really anything that's over 317? And they're saying that's the average? No, this would be the average, the better average, because it's closer to more points. What threw this one off? The 749. This 749 would be an outlier, which would screw this number up. That's why that one's so high. That's why the mean is not appropriate and the median is a better center of variation to go by. I did the same thing on slide 3. I already ordered them, so take a moment to pause. Data with one variable, such as test scores, are called univariate. So unicorn, uni, 1. These data can be described by a measure of center. So the measures of center are going to be the mean, median, and mode. So it says the ages seated in the one row of a movie theater are blah, 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 blah. Find the mean, median, mode, and range of the data set. So the mean, we need to add them up. Median, find the middle. Mode, most occurring. Range, oldest person minus youngest person. 56 minus 15, just because these are quick. So the ages are a 41-year gap. The mode, the one that occurs the most, sometimes this will be none, but 19 happens to be the one in this case. 19 years old, 19 years. The median, something between 19 and 24. So there's 5 there, so 5 divided by 2 is 2.5, so 19 plus 2.5 will be 21.5 years old. Or you could add those 2 up and divide by 2. And the mean, we have to add them all up. 15 plus 16 plus 19 plus, I missed it, 16 plus 19 plus 19 plus 24 plus 30 plus 33 plus 56. It's 212 divided by 1, 2, 3, 4, 5, 6, 7, 8. 26.5. So what would be a good average for this? You would pick between the mean, median, and mode. And really these are all pretty close, so probably the best one would be something in the mid-range here. I would probably go with the mean being the better one, just because it's kind of in the middle of all those numbers, the average age. But we have some below, some above. But these are just averages, mean, median, and mode, and which one is the best average. Okay, so we have a 5-number summary. Is what it's going to be called in ALEKS, it's going to be called on tests and things like that. And we have a vocab word. Quantitative data are data that can be measured. A set of quantitative data can be divided into 4 equal parts called quartiles. So we have the lower quartile, the middle, and the upper quartile, and then we're going to have whiskers. So this is going to be our box and whisker plots. So we have the median, which we talked about before, in the middle of this data set. The median of the data values less than the median is called the lower quartile or the first quartile. The median of the upper half is called the third quartile or Q3. If two numbers are in the middle for the median, you'll have to find the mean of the two. We've already talked about that, adding them up and dividing by 2. If the median is 2 numbers, those numbers belong to the upper and lower half, so you have to split the numbers. If there's only one number in the middle, which this one we would have to split the 38 with the upper, 36 with the lower. But if there's only one number, we would ignore it. It just belongs to itself while finding the Q1 and Q3. Another vocab word, this 5-number summary, which includes the minimum value, Q1, median, Q3, and the maximum value, provides a numerical way of characterizing a set of data. The 5-number summary can be described visually with a box plot or box and whisker plot. So they said it gets broken down into 4 equal chunks, not equal, 4 different chunks. The lower half and the upper half, and then the halves are broken into a whisker and part of the box. Okay. I took the liberty again here to order that, so please do so. The data for the average temperatures for 15 days in May are shown on the table. Find the 5-number summary. So first step is to write the data from least to greatest. So the 5-number summary includes the minimum, and then we move on to Q1, median, Q3, maximum. Minimum, Q1, median, Q3, and then the max. So the minimum is easy to pick out, it's the lowest one, 68. The max is easy to pick out, 76. The median, we have to cross out our numbers. So the median is 74. There's only one number in the middle. Now to find the Q1 and Q3, we ignore the 74 and just look at this part. So find the median of this one, gives us 71. And this would be degrees. These would all be degrees Fahrenheit, or yeah. And Q3, $75 degrees Fahrenheit. So the lowest it got those 12 days was 68. The highest was 76. The average, you could go with a median, is 74. But it might range anywhere from 71 to 75. That's just what that data is telling us. Draw a box plot of the data. Draw a number line that includes the least and the greatest numbers. So we're going to label this box plot, put a title on it. Temperature, I want to say in May. So the first dot will be 68. That's going to be right above the number line. Second dot is 71. Third dot is 74. Fourth dot is 75. Last dot is 76. The first and second dot get connected. A box gets around the first, second, and fourth line to the third, and the last whisker on the 4th to 5th. So it looks like the data is pretty spread out in the lower half, it's pretty spread out, and then these ones are pretty close data. That's what that's telling us. Same thing on slide 7. I already ordered them. Find the 5-number summary. So the min is 4. Q1, we're going to have to do that. So we have to find the median, which I can just look at this one and say is 6. So the Q1 is going to be 5 and 7 for the Q3 because it's nice and easy to see those ones. So Q1 is 5. This is calories, I guess, per minute. Median is next. 6 calories. The Q3 would be 7 calories. It's kind of getting on the high end there. And the max, 8 calories. So jogging has 8 calories per minute. And the lowest one, just walking, it looks like. An average, if you wanted to burn more calories on average and maybe not do the hardest work, play soccer or go jump rope or basketball. Draw box and whisker plot. First dot is at 4. Next dot is at 5. Next dot is at 6. Next dot is 7. And next is at 8. This is a very symmetrical box and whisker plot because everything is even. Everything is the same amount of space. Never let the fear of striking out keep you from playing the game. Have a great day.